Hi, I'm Pat McCormick. I teach biology here at JCJC. Man's fascination with the heavens is as old as recorded history. Long before there were telescopes and prehistoric man gazed upon the stars. Pictographs and hieroglyphs depict observations of wonder and fear. Astronomy is the study of celestial objects, including stars, planets, and galaxies. One of the oldest sciences, with the beginnings around 3000 BC, it takes its name from the Greek words star and law. Ancient astronomers carefully observed the relative positions of stars, as well as the time of year when a particular star or group of stars was visible in the night sky. Celestial information, particularly that associated with cycles such as phases of the moon, were important to ancient societies as the basis for establishing calendars. The calm and predictable reliability of astronomical cycles governed agricultural activity and religious observations and festivals. Eclipses and planetary motions were often interpreted as omens. In 1901, sponge divers off the coast of Antikythera, Greece, an island community south of Athens, made a spectacular find in the shipwreck of an early sailing vessel. It appeared to look like a rock with a gear wheel embedded in it. The ship is thought to have been an ancient Roman pirate ship, but study has revealed that the device is unmistakably Greek in origin. It is thought that perhaps the cargo ship contained plundered Greek artifacts. No larger than a shoebox, the bronze metal of the device had been corroded by the effects of the salt water and was not immediately identified. But as the significance of the astronomical device was recognized, it generated tremendous interest and has now become known as the Antikythera mechanism. It is a stunningly complex analog computer. This unique geared device was constructed around the end of the 2nd century BC, coinciding with the height of the development of sophisticated Greek science. It has puzzled and intrigued historians of science and technology ever since its discovery. This 2,000-year-old computer has a mechanism technically more complex than any known device for at least 1,000 years afterwards. It confirms that the ancient Greeks had developed extremely advanced levels of craftsmanship and scientific knowledge. Extraordinarily sophisticated, the device employs an arrangement of more than 30 epicyclic gear wheels and dials for its calculations. The level of miniaturization and complexity is remarkable, with some parts resembling those used by 18th century clockmakers. It is in over 80 pieces and is stored in controlled conditions at the National Archaeological Museum in Athens. It is too priceless and unique to leave the museum. It cannot be touched. Researchers must go to Athens for its study. Because the gears and the inscriptions upon the faces are only fragmentary, its specific functions have remained somewhat controversial. The first formal report of its investigation appeared in June of 1959 in an issue of Scientific American. It showcased the work of Derek J. DeSala Price, a British professor of history of science at Yale. Price undertook a reconstruction of the mechanism, and this currently is housed along with the original in the museum at Athens. Several others have followed with additional reconstructions. Recreating the workings of the mechanism was difficult, a painstaking process, involving astronomers, mathematicians, computer experts, script analysts, and conservation experts. The surviving fragments have been studied most recently using high-resolution X-ray tomography and surface imaging using sophisticated state-of-the-art instrumentation. The mechanism is described as pure genius, and many of the newest findings have been reported in the November 2006 issue of the scientific journal Nature. Researchers have been able to reconstruct more of the gear functions and decipher nearly 95% of the inscriptions of the surviving fragments. One surprise of the most recent research was the revelation of hidden inscriptions on many of the fragments. The mechanism reveals an unexpected degree of technical sophistication, predicting the positions of the sun and moon and locations of the planets. It predicted lunar and solar eclipses on the basis of Babylonian arithmetic progression cycles. The use of differential gears enabled the mechanism to add or subtract angular velocities. The differential was used to compute the synodic lunar cycle by subtracting the effects of the sun's movement from lunar movement. It utilizes the same calendar as found in Syracuse, home of the famous Archimedes. Cicero, writing in the 1st century BC, mentions a similar instrument. The sophisticated 2,000-year-old astronomical marvel also revealed a cultural function, a curious Olympiad dial which held enormous social significance as it provided timings for the immensely popular games. The device's actual purpose still remains unclear, as we don't know its full range of capabilities. But the scientific value of this gear mechanism is indisputable because it anticipates the results of the law of universal gravitation, formulated by Isaac Newton in 1687, 19 centuries later. It also anticipates and uses the theory of a sun-centered universe, proposed by Copernicus in 1543. And finally, it anticipates, from the study of its epicyclic gearings, the Principles of Mechanism, published by Robert Willis in 1841.